The information I'm going to present today is related and came from the literature review that we put together for National Pork Board last summer, and we're glad to have this opportunity to share some of these results to the symposium today. Marketing weight is an important decision variable for any of the finishing pig production. Looking at the historic trend, we see a continuous increase of marketing weight, which is driven by the dilution of fixed production cost. And also, our industry has been focusing on the selection of lean gain potential of the pigs, which allows us to increase the marketing weight without a dramatic increase or penalty on the feed efficiency. However, as the marketing weight change, there are a lot of factors are associated. For example, genetics, nutritional programs, animal health and welfare, and of course, meat quality traits. So the idea or the objective of this literature review is to help us understand what do we currently know about feeding heavy pigs and to identify areas for future research needs. And the results of this literature review were partitioned into two sections. And the first part is a literature summary of studies that reported growth performance, carcass characteristics, and meat quality of pigs that raised the two different marketing weights. A total of 35 studies were identified that fits into this topic, and we decided to keep those where their greatest marketing weight tested in the study was above 125 kilograms. By setting this threshold, we screen out those studies that should give us enough information to help us understand, extrapolate the trend for the increasing marketing weight. We also took out those studies where they used the restricted feeding or uncommonly used the genetic lines, such as the Italian Iberian lines that is quite different from what we have in the United States. For each of this study, we did a simple linear regression to generate the sensitivity of each parameter and see how they change with every 10 kilogram increase in marketing weight. And doing that, our assumption is all these parameters have linear response to the increased marketing weight without any interaction with other factors such as gender or the effect of feeding growth promoters. So the next few tables are going to present the results from this regression analysis. And for the growth performance, this table, we included detailed information for each of the studies. For example, the initial body weights and the different marketing weights tested by the researchers, and also stocking density and floor space allowance. Looking at these numbers, we can easily tell that most of these studies were done in the research farms, and their stocking density are much lower than what we typically see in the commercial settings. So it's always keeping that in mind that these studies could be affected how the pigs, the stocking densities are going to affect how the pigs respond to the increased marketing weight. The last three columns present how the average daily gain, feed intake, and gain to feed ratios, how they change with every 10 kilogram increase in marketing weight. And these responses are based on cumulative growth performance from initial to marketing weights. So it's very much look like looking at the closeout data. And the positive values will represent an increase in response, and the negative values means a decrease. Looking at the average daily gain first, a lot of variability was observed. 8 out of the 14 studies reported decreased average daily gain, but the other half of the literature reported increased average daily gain with greater marketing weight. As we would expect, the average daily feed intake increased with greater marketing weight with an average of 78 grams for every 10 kilogram increase in marketing weight. With the only two exceptions from Latour 2004 and Latour 2008. In both of these studies, severe heat stress condition was observed, and therefore we see them as kind of outliers. And when we calculate for the average response, we took those two studies out from the calculation. Since we have unchanged average daily gain increased appetite feed intake. Not surprisingly, the gain-to-feed ratio decreased with greater marketing weight. And the average of 0.011 was slightly lower than the adjusting factor that we typically use for the closeout report. Here are a lot more data for the carcass composition. Generally, the results from these studies were more consistent, and on an average, the carcass yield increased by about 0.41% for every 10 kilogram increase in marketing weight. And as we would expect, back fat thickness increased, but the percentage of fat-free lean decreased with greater marketing weight, which reflected the increased fatness of the heavier carcasses. In addition, we see increased loin muscle area and carcass length by 1.8 and 2.2 units respectively for every 10 kilogram increase in marketing weight. One thing I found is quite interesting is that 14 studies reported the yields for primal cuts. And those studies suggest that the yields for belly actually increased with greater marketing weight, which is at the expense of decreased yields for loin, shoulder, and ham, which we refer to as the lean cuts. Move on to the meat quality measurements. Most of the studies that we reviewed has reported slightly decreased initial or ultimate pH in the pork from heavier pigs. However, the magnitude was not huge. L-star is an instrumental color measurement for the lightness of meat product, and literature suggests that there is variable results. 5 out of the 9 studies reported decreased lightness. 4 studies reported increased lightness of pork from heavier carcass. A-star measures the redness color of meat product, and the literature agreed that with marketing weight increase, we tend to see slightly increase the redness color by about 0.3%, 0.3 unit for every 10 kilogram increase in marketing weight. B-star measures the yellowish color in meat product, and the 7 studies again reported variable results with increase reported in 3 studies and decrease in 3 studies, and 4 studies reported increase. On an average, the 3 plots decreased by 0.11% for every 10 kilogram increase in marketing weight. However, this number was pretty much driven by this one single observation, and most of the other studies reported pretty consistent increase of 3 plots with greater marketing weight. And so more data are needed to verify this response. Finally, Warner-Baszler shear force is a measurement for the pork tenderness, and the results increased, tenderness increased in 5 studies, but decreased in the rest of the 3 studies. Only a handful of studies were identified that reported the pork fat quality or the sensory properties of pork from heavier pigs, both in Lofiego in 2005 and Raj in 2010. They both reported increased saturation of the pork fat from pigs in heavier weights. Particularly, the saturated fatty acids increased by about 0.4% for every 10 kilogram increase in marketing weight, which is at the expense of decreased concentration of polyunsaturated fatty acids. And this results in a slightly decreased iodine value. Not surprisingly, literature suggests the increased intramuscular fat content and marbling score with greater marketing weight. Only 2 studies reported the sensory properties of pork from heavier pigs. One of them reported increased tenderness and juiciness. However, the other study reported the opposite result. Some study also suggests there is an increased presence of off-flavor content as we go to heavier marketing weights. However, if the pork is cooked, then there's no difference between the heavier or lighter pigs in terms of their flavor profile. To summarize what we found in the first section of this literature review, as we increase marketing weight, we tend to see unchanged average daily gain, significantly increased average daily feed intake with poor feed efficiency. And for carcass characteristics, measurements that represent the body size or the fatness of the carcass increased with marketing weight, but those parameters that represent the carcass leanness decreased. Also, as marketing weight increased, we tend to see slightly decreased pork pH, but increased concentration of saturated fatty acids and intramuscular fat content. Finally, inconsistent results were observed for many meat quality measurements, such as color, three-ploss, shear force, and sensory properties. Future research are definitely needed in these areas, probably especially for pigs with modern genetic lines. So from what the findings so far, our question is, what can we do to mitigate some of these negative impacts from increasing marketing weight, especially how to improve the feed efficiency or decrease the fat deposition during the late finishing period? Which leads us to the next section of this presentation, where I want to discuss what factors do we need to consider when we increase marketing weight. First of all, nutrition, of course. We knew that heavy pigs had decreased the lean deposition rate, but increased the maintenance requirement. So there's no doubt the heavy pigs will have their unique or specific nutritional requirements. However, unfortunately, there's limited information we found from the literature to give us guidelines for the nutritional requirements for heavy pigs. Our NRC 2012 only covers pigs up to 140 kilograms. And we found nutritional programs from European countries. However, these programs were designed for pigs that has different genetic lines or nutritional programs, because some of these pigs, or most of these heavy pigs, were designed for ham production, which is quite different from what we have in North America. First, look at the amino acids. Little information is available for the SID lysine requirements only from NRC 2012 and a study by Manini in 1997 using a factorial approach. However, these values have not been validated by any empirical studies. So cautions are needed when you apply these numbers to your production system. Clearly, the SID lysine requirement decreased with greater marketing weight, and the magnitude was not huge. However, adjustments to your diet formulation may be potentially needed, because even a slight or a small decrease in the feed cost in late finishing diet can be economically significant due to the high volume of feed consumption. Also, ideal amino acids to lysine ratios could be different in heavier pigs due to their different tissue turnover rate or maintenance requirements. For example, back in 1995, Han and Baker suggest that these several amino acids are needed in higher concentration relative to lysine in heavier pigs compared with those lighter pigs. One of the most popular topics about feeding heavy pigs is how to limit the fat deposition rate using nutritional tools. Feed additives or strategies have been proposed, for example, using the ractopamine or porcine somatotropins are proved to be as effective or even more effective in heavier pigs than the lighter pigs. And for feeding strategies, the idea of the restricted feeding program is that to provide enough energy for a lean deposition of pigs, however, limit the energy partitioning to the fat deposition. Nittel in 2012 suggests that pigs raised to from 100 to 150 kilograms, so definitely heavy pigs, those pigs were given only 70% of their ad libitum feed intake, resulted in the same amount of lysine protein deposition, but lower deposition of fat content compared with the pigs fed 95% of their ad libitum feed intake. However, the challenge of using this strategy is that the heavy pigs, even though they may limit their fat deposition or slight improvement in feed efficiency, however, it's often at the expense of decreased growth rate. And also thinking about the applicability, at least in the current US industry, thinking about the current feeder designs and additional labor cost. Another approach to achieve slightly lower energy intake of the pig is to feed low energy diets. However, the problem is if the pigs were given adequate floor space and feeder space, they're going to increase their feed intake to compensate for the decreased energy density of the diets. Let's switch gears from talking about the nutritional requirements to the barn designs or facility management. One of the challenges of feeding heavy pig is to deal with the decreased floor space allowance as pigs get heavier. K value is a measurement for the floor space allowance, and back in 2006, Gang Yu has proposed the critical K value and suggests that if we go down below this number, decrease the feed intake and gain rate will be expected. So based on this critical K value, we have determined an average increment of 0.02 square meter is needed for every, per pig is needed for every 5 kilogram increase in the marketing weight. To mitigate the negative impacts from limited floor space, we can use removal strategy or serial marketing. However, the studies we done with the removal strategies were done with pigs less than 130 kilograms, and definitely more data are needed for heavy pigs. Not only the floor space can limit the growth performance of pigs, the feeder space as well. The size of the feeder host need to be slightly wider than the shoulder width of the pigs, which can be estimated using the Petherick equation. Also, the height of the waters should also be adjustable to the shoulder height of the pigs to ensure they have easy access to water. Lots of our production systems are moving to wet and dry feeders, which takes out a lot of this concern, but still, heavy pigs consume more water every day. So the size of the water pipes need to be large enough to ensure enough water flow into the barn. Also, heavy pigs produce more heat and is more vulnerable to the heat stress. So there's an increased requirements for the barn ventilation, and we can use this equation to estimate the heat production of the pigs and to adjust for your ventilation. Move on to the animal health and welfare concerns. As marketing weight increase, there won't be surprised to see a slightly increased mortality rate. However, this could be simply the results of increased number of risk days as the pigs were kept in the barn for a longer period of time. The increased pig days also is going to challenge our current vaccination protocol. So questions such as how much longer our vaccines can protect the pigs, or do we need an additional dose of the vaccine to get the pigs through the heavy weights? Also, the increased body weight is going to put more stress on the joint and skeletal system of the heavy pigs, and this could be additional considerations needed. Transportation of heavy pig is a critical process, and Paul did a really good job to help us understand this. Generally, heavy pigs can be exhausted faster during the transportation, and it can be more susceptible to the change of weather conditions. So the increased mortality rates can be expected and actually was observed for the transporting the heavy pigs than the lighter pigs. Paul also mentioned that as pigs get heavier, they need more space on the trucks, and therefore the number of pigs we can fit into standard trucks are decreased. So adjustments to the size or the design of the trucks may be needed to improve the transportation efficiency. Also, since the heavy pigs are more reluctant to move and lower ramp angles are needed, and some data suggest that 15-degree or less are needed for pigs greater than 125 kilograms. Finally, when the pigs arrive the packing plants, the increase the size and weight of the carcasses are going to greatly challenge our packing facility. For example, the heavier pigs may slow down the line movement, which could be the result of limited capacity for CO2 chambers if there's no more room for adjustments. Also, in some packing systems, handling heavier carcasses could be challenging. Also, carcass length will increase with marketing weight, and therefore increase the height of the rails may be needed for proper exsanguination. Also, deeper scalding tanks and bigger carcass handling equipment and storage capacity is going to be needed. Probably the biggest concern from the packing plants is the increased requirements for cooling the heavier carcasses. Currently, there's no study has been identified that give us estimation for the airflow or chilling speed required for the heavier pigs. In addition, not only for the primary plants, pigs shifted to the coal plants also is going to be heavier, and some of these plants are running at their full capacity and may not have any adjustments or room for adjustments. Some additional considerations are going to be needed. Finally, we need better understanding on the customer preference of pork product from heavier pigs, especially the size, weight, or the thickness of the pork products. To summarize what we found in this literature review, based on the historic trend, we'll continue to see increased marketing weight driven by the dilution of fixed production cost. And to achieve that, a continuous effort on the genetic selection for lean gain potential of pigs is going to be needed. And to feed the heavy pigs, the key is to how to limit the fat deposition during the late finishing period. However, limited information is currently available to provide us the nutritional guidelines for pigs greater than 140 kilograms. Finally, the facility designs and packing plant equipment need to be adjusted for the increased biological and physical requirements of the pigs. And in this review project, we provided recommendations for some of the adjustments needed. With that, I would like to thank National